is my real test. To train them is my cause. I will travel across the land, searching far and wide. Each Pokemon to understand the power that's inside.
Alright, so how do you get a Pikachu on a bus? That is actually a riddle that we're going to be doing for our riddle this week. It is actually a joke. Let's see if you can come up with the answer by the end here. Alright, let's take a look at these three circles. These three circles, as you can tell, are different sizes. The green one is medium size, the black one's the smallest, the blue one's the largest. I want you to think about if all these circles have the same measurement of degrees, total degrees, in one whole circle, looking at each one of these. And hopefully you have decided that all three of these circles have 360 degrees, because the size of the circle does not matter. So each one of these has 360 degrees inside of them. And the way to think about that is if you were to start here and go all the way around the circle, just as beautiful as my circle is, as perfect as it is, that is 360 degrees to go all the way around. So size does not matter for the size of a circle. All circles have 360 degrees. But does the size of an angle, the way it's been drawn, especially the two rays, let's say these two rays versus these two rays, do these two rays, or these two angles that they form, do they have the same measurement as well? And you might be beginning to think that the black rays have a larger measurement. That is actually not true, because even though these are not the same size rays, size does not matter for angles either. If I told you that the red angle was 25 degrees, let me just show you that the black angle is actually the exact same measurement. And the way that I can show you that is because I can put the red one right on top of the black one, and you'll see that they actually form the same amount of turn in between the two rays here. So the red angle, which is 25 degrees, and the black angle are also 25 degrees. The size of the rays does not matter. I could even shorten the red rays themselves, and that's still not going to change the size of the angle. So for example, I can make the red rays even smaller. That's still not going to change the size of the angle, because the angle itself is right here. It is the amount of turn in between the two rays. It does not matter how long the rays are or how short the rays are. It's actually the amount of turn in between the two rays that matters. Now let's take a look at these 6 circles. These 6 circles, I'm going to have you help me try and figure out how many degrees is in each one of these pieces. So for example, I want to think about just having one whole piece. And we've already talked about how one whole piece in a circle is 360 degrees. The reason for that is because 360 divided into one piece is equal to 360 degrees for each piece, and in this case it's just one piece, so that one piece is 360 degrees. Now if I wanted to split this into 2 pieces, we know that a straight line has 180 degrees in it. So if I split it into 2 pieces, 2 equal sized pieces, 360 divided into 2 pieces is equal to 180 degrees, which is why a straight line has 180 degrees as well. Let's look at what if we wanted to split it into 3 pieces. 3 pieces on a circle can kind of look like a peace sign if they are equally sized. 360 divided by 3 pieces equals 120 degrees, meaning that each one of these pieces is 120 degrees. Each one of these angles, as you can tell, is an obtuse angle. It is larger than 90 degrees. Now, if I wanted it to be into 4 pieces, 360 divided by 4 is, and sorry about my handwriting here, 360 divided by 4 is equal to 90 degrees. So each one of these is equal to 90 degrees, and that should make sense because each one of these is actually a right angle, and all right angles have exactly 90 degrees. Now, if I was to look at this piece right here and I wanted to take this circle and split it into 5 pieces, 360 divided by 5 tells me that each one of the pieces should have 72 degrees inside of it. So that means that the turn of each angle should be 72 degrees. Now, with that said, 360 divided by 5 being equal to 72 degrees, I'm going to split this into 5 pieces, thinking of it like a person. Here's the head and the 2 arms being stretched out, and then the legs as well. You now have 5 pieces. Each one of these should be 72 degrees. So each one of these is an acute angle. If I wanted to split it into 6 pieces, 360 divided by 6, that's actually the quick trick, because 360 divided by 6, so you can do 36 divided by 6, which is equal to 6, and then attach 1 0, which is equal to 60. So if I split this into 6 pieces, I know it's not going to be perfectly drawn, but I will try. Each one of these should be equal to 60 degrees. Notice that if I have 3 pieces put together, 60 plus 60 plus 60 equals 180, which is why, if you look at half of a circle, is 180 degrees. So half of a circle on this circle is also 180 degrees. Now, all of that makes a difference in terms of angles, because if I'm taking a look at angles here, I'm taking a look at some angles, like my red and my black. Looking at circles, let's say I draw a circle around here and a circle around here. Both these circles have 360 degrees, and as I told you before, both of these measure 25 degrees. So it doesn't matter the size of the circle. It can look like this, it can look like these. All of them have 360 degrees, but if you start splitting them into pieces, each one is going to have a different measurement depending on the number of pieces. Let's look at a clock, because a clock is a very helpful tool as well in terms of looking at angles in a circle. If I look at a clock can be split into 12 pieces because there are 12 different numbers on a clock. So right now I'm just dividing it into those 12 pieces. And I know they're not beautiful, but they should all intersect into the center area. And if I split it into 12 pieces, 360 divided by 12 is equal to 30 degrees, because 36 divided by 12 is equal to 3. Attach 1 0, and you've got 30. So each one of these is 30 degrees. Now, 30 times 12 is equal to 360 degrees. And I know that, for example, if the hands of a clock were pointing at the 12 and to the 1, that would be equal to 30 degrees. Now, if I was looking at the clock and let's say one of the hands was pointing at the 12 and halfway in between the 1, well, a 30-degree angle split into 2 pieces is equal to 15 degrees in each piece. So that means if the hour or minute hand is in between 2 numbers, you can think of that like 15 degrees. So, for example, this measurement from 12 to halfway in between the 12 and the 1, so this blue angle right here, is equal to 15 degrees. Now, all of these can actually be measured with a protractor, because a protractor is a tool that you can use to find out the exact number of degrees of an angle. Now, this protractor here that I have is half of a circle, and we know that a whole circle is 360 degrees, so half of a circle should be 180, which is why you see the numbers only going up to 180 degrees. Now, there are 2 sets of numbers on here. One set of numbers is for use for acute angles, and one set of numbers is for obtuse angles. So whenever you're measuring angles, you have to ask yourself if it's acute or obtuse, and based on the answer to that question, that's the set of numbers that you look at. Now, protractors can be in all sorts of different sizes. You can have small ones, you can have large ones. In this case, I'm just going to use a protractor that's about this size. You can also rotate a protractor, because protractors need to be rotated so that it is lined up with your rays. Some protractors can be 180 degrees or half a circle. Some can be 360, like this one right here. Notice all the numbers going around on a whole circle go up to 360 degrees, whereas on a half circle is 180 degrees. Now let's take a look at how you would actually use this type of protractor. First thing that you do is you find the vertex of an angle. Vertex of an angle is where the 2 rays intersect. So I'm putting a red point on the vertex of this angle. And what you're going to do is you're going to, usually on a protractor, there's a hole. On mine, there's actually a point of intersection. This intersection is 2 perpendicular lines that form right angles. So right here is where that hole would be on most protractors, that point right in the middle. And you line that up onto your vertex. And once that's lined up onto your vertex, then you have to try and rotate the protractor so that one of your rays cuts through the 0. In other words, it's in line with the 0. So here's a 0 right here on my protractor. I need to make sure that that 0 is right in line with the ray of my angle. And once it's in line with the ray of my angle, I then look at the other ray and I look and see what number does it go through. Now you'll notice that it's going through a number that's pretty close to 20 or close to 160. Now, since this is an acute angle, we have to look at the smaller set of numbers because acute angles means that's less than 90 degrees. So looking at this angle right here, I know that the measurement must be in between 10 and 20, and it's not exactly on the 20, so I would probably say that this measurement is about 19 degrees. So let's just double check our answer. It says this angle is 19 degrees. So let's just review with another one. I'm going to find the point of intersection of the two rays, which is called the vertex, line it up with a point of intersection or the hole of my protractor. And then I have to rotate the protractor to try to make sure that the 0 is cut in half or is in line with one of my rays. So I did that now. And it is pretty much going through either it's in between 100 and 110 or 70 and 80. And since it's an obtuse angle, I'm going to look at the larger set of numbers. So I know it's in between 100 and 110. Now, notice how the line of the ray does not go far enough all the way out. It's not a good idea to eyeball. It's actually better to try and extend the line or to use a smaller protractor. Now, oftentimes you don't have a smaller protractor, but I can actually shrink this down and kind of cheat a little bit so that the line of the ray actually extends. There's no problem with actually extending the line of the ray because we know that it goes infinitely in that direction. And so that's not going to change our measurement. As we looked at before, the length of the rays does not change the angle measurement. So looking here, it's in between 100 and 110. Well, here is the line that would be 105. So I know it's 106, 107 degrees. You might even say it might be 108 degrees. So let's just see what they say. And the angle is 107 degrees. Now, that's all fine and dandy for acute and obtuse. You might even have a right angle. Right angles are actually even easier than obtuse or acute because they should be exactly 90 degrees. Notice how this ray goes right in line with the 90. And I'm just going to shrink it down so you can see it goes right through the 90. And notice how it's also cutting through my 0, and the vertex is right on top of the hole or the center of my protractor here. So this should be 90 degrees. Now that's great, but most of the time you don't always have angles drawn for you, and you actually have to draw the angle itself. So let's take a look at how you would actually draw an angle. Let's say I want to draw an angle that is 145 degrees. What you do is, this is a ray that's already been drawn. Let's assume that the point of the ray is right here, and the arrow, meaning that's going infinitely in this direction, is over here. What you need to do is assume that this point right here is the vertex or the point of intersection for an angle. An angle needs two rays, so if this is one ray, you're going to have to draw the second one. What you do is you put the protractor right on top of the vertex. You make sure that the 0 is cut in half or in line with the 0 with one of the rays. And then if I'm trying to find the 145 degree angle, let me just shift this over because I'm going to probably run out of room here. So I'm going to move him over and move this down. The reason why I know I'm going to run out of room is because when I'm trying to find 145 degrees on this protractor, I see 145 degrees over here, which is this mark here, and I also see 145 degrees over here. With that said, I know that only one of those can be correct. And basically, once I put my mark, I have to decide which one is my obtuse or acute angle. And when you go to make your mark, you ask yourself that, so you don't actually make two different marks, although you can, and then decide, well, if I was to make another ray, for example, going in this direction, this is not a 145 degree angle because it is an acute angle, and I need to make sure it's an obtuse angle. However, if I was to connect these two dots, this right here should be a 145 degree angle. So if I go to check it, put it on top of the protractor, it goes pretty much right through the 145 degree mark. And between the 140 and 150, right in between is 145 degrees. So let me just review that one more time. If I was to do it with, let's say, a 14 degree angle, which is a pretty small acute angle. So looking here, I know that I'm going to put my vertex or my point there, my arrow here. That's one of the rays. Now I need to make my second ray. I'm going to put the protractor on top, make sure it cuts through the 0, and then I'm going to find the 14. Now there are two different 14s on this protractor. Here's in between 10 and 20. The 14 would be about here. And then in between the 10 and 20 over here, the 14 would be about, not there, there. So that's about the 14 degree mark over there. Now I know 14 degrees is an acute angle, so I know if I was to make my second ray, you would use a straight edge here. Luckily, since I'm on the computer, I can use tools to actually make that ray. But this would be a 14 degree angle, whereas this angle over here is an obtuse angle, which is a lot larger. So that is not going to be a 14 degree angle, whereas this is. And so if I was to double check that, I should, if I measure it correctly, should be right on the 14. It might be a little bit off for some of you, especially if you're doing it with a pencil, which is why I give you a 5 degree leeway above or below 14 degrees. All right, and that kind of wraps up the video, so I'm going to leave you with the joke one more time. And the only hint that I can really give you is this next section of the song. It's pretty much right underneath your nose. All right, best of luck.